Hello, this presentation is on angles and angle measure. We will focus on angles in standard position. When do we say that an angle is in standard position? Well, there are some conditions that must be satisfied. The first condition is the vertex has to be at the origin. So the vertex has to be at the origin. Second condition, the initial side is a positive x-axis. Here's the initial side. Initial side must be at the positive x-axis. And the third condition, the terminal side must be obtained by rotating from its initial side. So here's the terminal side. As you see, the rotation starts from the initial side. If these conditions are satisfied, then we say that the angle is in standard position. Throughout the trig functions, we will only work with angles in standard position. Now, second thing is some angle measure are positive and some angle measures are negative. So positive versus negative angle measure. Now, we say that an angle, its measure is positive if the terminal side is rotated counterclockwise. So if the terminal side is rotated counterclockwise, then the angle is positive. If the terminal side is rotated clockwise, then the angle is negative. As simple as this. Here's example 1. The question says, draw the following angles in standard position. So let's start with the 210. 210 is a bit greater than 180. So this is 180. So first we start from the initial side must be on the positive x-axis, as you see. And then we count. So this is 180. And you add 30 to get 210. So that's the 210 angle in standard position. Second one is negative 40, or example B. Negative 40, so that's a negative measure. So it means we start from the positive x-axis, and then we need to rotate clockwise. We don't go far because negative 40 is small angle. Now this is negative 40 degrees. 470, that's greater than 360. So again, we start from the positive x-axis. It's a positive angle, or the measure of the angle is positive. So we must rotate counterclockwise. So counterclockwise, this is so far 360. And from 360 to get to 70, you need an extra 110. So that's 90, and then an extra 20. So approximately this is the angle. This is 470 degrees. Now let's move on to the next concept, which is coterminal angles. So the word coterminal has the co, the prefix co, and terminal. Co, we can think of co-workers, cohabitants, colleagues, means they have something in common. Same here, coterminal. It means the terminal side of, let's say, 2, 3, or 4 angles is shared between these angles. the terminal side is shared between those angles. So we say those angles are coterminal angles. If you look at the figure, look at the 60 degrees angle. 60 degrees angle. Now, negative 300 degrees has the same terminal as a 60. They got the same terminal as 60, so they are coterminal angles. But we can find more angles that are coterminal. We can look also at this angle, which is 420. Let's work on example 2. Example 2 says, for each angle below, find the coterminal angle theta where the angle measure is in between 360 and 360. So it means cannot be greater than 360, cannot be smaller than negative 360. Let's make a figure for the first example. Then once we understand what we need to do, then we can just evaluate or do some computations, and then we find the coterminal angles. So if we sketch the figure, 210 is a bit greater than 180. 180 at the 30 degrees. So that's 210. Now, to find a coterminal angle whose measure in between negative 360 and 360, in this case, that angle must be negative, because this is the only angle that is less than 360, greater than negative 360, and it is coterminal with 210. You wouldn't be able to find another one. How do we find this angle? Well, since this angle is negative, see the red angle is negative because we're rotating clockwise. Then if I do 210 minus 360, because really, if you want to find that red angle, what we can do is we can look at it this way. This is 360. The entire rotation is 360. You need to subtract 210. So 360 minus 210, the blue minus the green will give you the red. However, because I want negative angle, then I just switch the order. Then I do 210 minus 360. 210 minus 360. And in this case, the answer would be negative 150. Now, coterminal angles can be found by adding 360 or subtracting 360. So if you already have a positive angle, then if you subtract 360, you'll find the coterminal angle. If you have a negative angle, you add 360. So let's make a figure for example B. Negative 120, it's a bit greater than negative 90. It's greater than negative 90 by negative 30 degrees. So this is our angle, negative 120. Now, obviously, the coterminal angle to negative 120, whose measure is in between negative 360 and 360, is this angle. How do I find this angle? Well, it looks like 360 minus 120, you got that positive angle. This is positive because it's counterclockwise. You can tell by looking at it, this is 360, the whole circle. So the whole circle minus the green angle, or the blue circle angle minus the green angle, it will be the red angle. So as I said, if the angle is negative, you add 360. So you do negative 120 plus 360, which is 240. So it means 240 degrees and negative 120 degrees are coterminal angles. Now let's look at example C. Example C, the angle is 580. It's already greater than 360. So obviously we're not going to add 360. That doesn't make sense because the angle is going to be greater than 580. And our condition says your coterminal angle cannot be greater than 360. So we have to subtract how much? 360. So 580 minus 360, that's 220. So 220 satisfy the condition, which is smaller than 360. In this example C, actually, we can find another angle that is negative. It's because the original angle, the given angle is 580. So if you do 220 minus 360, you're going to get a negative angle that is coterminal with 580. Example D is negative 800. So we have to add 360 because it's already negative 800 is already smaller than negative 360. So negative 800 plus 360, that's negative 440. But that's smaller than negative 360, so we need to keep on going. Negative 440 plus 360. So negative 440 plus 360 is negative 80. Well, since negative 380 is greater than negative 360 and smaller than 360, then this is coterminal angle. But if we add another 360, we're going to find another coterminal angle that is positive, and it's smaller than 360 and greater than negative 360. But since the question says find one coterminal angle, then this is sufficient. One important concept is radian measure of angles. So angles can be measured in degrees. They can also be measured in radians, and there are other units that we're not going to look at. We're just going to be measuring angles in degrees or radians. So looking at this concept, we can use something to simulate it. So let's say we talk about kilometers versus miles. So let's say this segment is 1 mile. This segment is 1 mile. This same segment in kilometers is 1.6 kilometers. Same distance from this point to this point. In miles is 1 mile. In kilometers is 1.6. So same idea with radian measure. Radian measure, for each 1 radian, 57.295 and so on degrees. And so it means the same angle in degrees will be 57 point, let's say if we round to 1 decimal place, so 57.3, and in radians will be 1 radian. But there is a better way how to compare radian unit with degree unit. So what we know is 360 degrees equivalent to 2 pi radians. 2 pi, which is 6.28 and so on. We got a lot of decimal places. So 2 pi radian is equivalent to 6.28318530717 and so on. And it keeps on going. 360, which is the entire circle, that's in degrees. 2 pi is in radians. So if we divide 360 by 2, we got 180. Well, we have to divide 2 pi by 2, so I mean 180 is equivalent to pi. And actually, this is the relationship that we're going to be working the most with. 180 degrees is equivalent to pi, which is 3.14. 90 degrees must be equivalent to pi over 2. because again, you divide 180 by 2, that's 90. Pi by 2 is pi over 2. And then the one that I already mentioned is the 57.2957795 and so on is equivalent to 1 radian. 1 radian. Now, I want to make sure that I'll address something. The angle measure, if it's given degrees, then you're always going to see that little degree notation, the little circle as an exponent. But if it's in radians, let's say 2 radians, normally we don't write anything. We just write 2 if it's 2 radians or any number. Just a hint. So this is in degrees or degree, and this is radians. Now let's look at the circle. We said 1 radian. 1 radian is approximately 57 degrees. So this is approximately 57 point something, and it's 1 radian. So if I add another 57, that's a bit greater than 90. That's 2 radians, and then 3 radians, 4, 5, 6. I missed it a little bit. You make a better one. So 57. Try not to miss it this time. So how many if we count? 1, 2, 3, 4, 5. I went a bit over. So 1, 2, 3, 4, 5, 6, and then this is the we said it's 6.28 and something because we said 2 pi is equivalent to 360 degrees, and 2 pi approximately is 6.28 if we round to two decimal places. So the counting would be 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and this small part is 0.28 radian. Okay? But you really don't have to worry about this. This is just to show you how the degrees and the radians compare to each other. And of course, the radian, it has an explanation on how the radian became the measure of one of the unit used to measure angles. And we're not going to go over that. We'll do it in maybe in another lesson. Let's go straight to how to convert from degrees to radians and then from radians to degrees. This is something that we need to know. Now, converting from degrees to radians, let's start with that. If you already have an angle that is in degrees, some angle n, its measure is in degrees, then to convert it to radians, I must divide by something in degrees and multiply by something in radians. Well, there is one relationship that I mentioned at the beginning of the lesson is we know that pi radian is equivalent to 180 degrees. So it means I put the pi radian on the top and 180 on the bottom. So the degree and the degree, they cancel each other. So what's left? It will be n, whatever that number is, multiplied by pi, which is 3.14 and so on, divided by 180. And with this, you have converted to radians, from degrees to radians. Now, if you convert from radians to degrees, the idea is the same. We're going to use the relationship that is, okay, pi is equivalent to 180 degrees. But this time, we need to put pi radian on the bottom and degrees on top, because we want to keep the degrees. So radians cancel. And what's left? N times 180 divided by pi. Whatever you get, that's your measure in degrees. Let's do some examples. The question says write the following degree measures as radians. We'll start with 30 degrees. 30 degrees, so we must multiply by pi radian, so we don't have to write radian each time. And we divide it by 180 because we want to divide degree by degree. Well, we can simplify. 30 by 30 is 1 times pi. And 180 divided by 30, that's 6. So pi over 6 radian. Example B, 135 degrees. Let's convert 135 degrees to something in radians. So we do the same thing. We're going to multiply by pi radians and divide it by 180 degrees. 135 over 180 simplifies to 3 over 4. So 3 pi over 4 radians. Let's do now the 240, which is example C, times pi radian over 180 degrees. So 240 over 180 simplifies to 4 over 3. So 4 pi over 3 radians. And then example D, negative 270. Make sure we don't forget that negative. So multiplied by pi radian divided by 180 again. So 270 divided by 180, which simplifies to 3 over 2. And don't forget the negative 3 pi over 2. 2, not 8. 2. Example 4 says write the following radian measures as degrees. Means we convert from radian to degrees. So the idea is the same, except that we're going to multiply by 180 divided by radian, because this measure is in radian, so we multiply by 180 degrees and we divide by pi radian. Looks like pi cancels with pi, and then what do we have left? We have 180 times 2, or negative 2 divided by 3. So 180 divided by 3, that's 60. 60 times 2 is 120, so negative 120 degrees. To example B, times 180 over pi radian. Again, we cancel the pi's. And then let's try to simplify whatever we have left. 180 divided by 6, that's 30. 30 times 7, that's 210 degrees. Let's do example C. Same thing, we multiplied by 180 divided by pi radian. Cross out the pi's. What's left? So 11 times 180 divided by 4. 495. 495 degrees. Last one, negative pi over 2 radians, so times 180 degrees divided by pi radian. We do the same thing, cross out the pi. What's left is negative 180 over 2, which is negative 90 degrees. Example 5, it says for each of the following, find coterminal angle theta, where the angle is theta is in between negative 2 pi and 2 pi. It means it has to be less than 2 pi and greater than negative 2 pi. The idea is the same as what I mean. The idea we can use to find the coterminal angle is the same with angles whose measure is in degrees. Now, the difference is we have to determine if, for example, 2 pi over 3 is that bigger than 2 pi, smaller than 2 pi, greater than negative 2 pi, or smaller than negative 2 pi. So obviously the 2 pi over 3 is for sure greater than negative 2 pi. Now, is it smaller than 2 pi? Yes, because 2 over 3 is definitely smaller than 2. See, 2 pi and 2 pi over 3. Now, the pi is a common factor. Now, what differentiates these two terms is the 2 and the 2 over 3. So 2 over 3, which is smaller than 2, divide 2 by 3 is smaller than 2. So it means this must be smaller than this one. Okay. Now, since it is smaller and we need to find the coterminal angle that is in between negative 2 pi and 2 pi, and all we have to do is subtract 2 pi. Because if you add 2 pi, then it's going to be greater than 2 pi. 2 pi over 3 plus 2 pi is an angle greater than 2 pi. And we cannot do that because that angle has to be smaller than 2 pi. But if we subtract 2 pi, then we're going to find an angle that is still greater than negative 2 pi. So let's find a common denominator here. So we got 2 pi over 3 minus 6 pi over 3. Multiply the 2 by 3 and 1 by 3. 2 pi minus 6 pi, that's negative 4 pi over 3. So negative 4 pi over 3 is a coterminal angle. Negative 7 pi over 4, well, that's obviously smaller than 2 pi, that's for sure, because it's negative. But is it smaller than negative 2 pi or bigger than negative 2 pi? Let's reason with it. Okay. On the number line, the negative 7 over 4 is not greater than 2 in absolute value. 7 over 4. 7 over 4 is smaller than 2. If it's negative, then it must be greater than negative 2. Because 7 over 4 is a number smaller than 2, but if it's negative, it will be greater. So if negative 7 over 4 pi, negative 7 over 4 is greater than negative 2, then this must be greater than this one. So we're okay. So what we need to do, we need to add 2 pi. We can't subtract, we need to add. In other words, if the angle given that is negative, we add 2 pi when we make sure that the angle we get is not greater than 2 pi. If it's positive, we subtract 2 pi. We'll make sure that our angle is not smaller than negative 2 pi. You can actually ignore this, what I was showing you. You can ignore this. Okay? So we're adding 2 pi. The common denominator is, so negative 7 pi plus 8 pi. This is over 4. That's over 4. Which is pi over 4. All right, now let's do the last one. This is 11 pi over 2, so we subtract 2 pi because this is positive. So 11 pi over 2 minus 4 pi over 2. 11 minus 4 is 7 pi over 2. Now, is 7 pi over 2 smaller than 2 pi? Well, 7 over 2 is greater than 2. So this is not smaller than 2 pi because this 7 over 2 is greater than 2, definitely. 7 over 2 is 3.5. It's greater than 2. So 3.5 pi, which is greater than 2 pi. So what do we have to do? We continue subtracting. 7 pi over 2 minus 2 pi again. So it's 7 pi over 2 minus 4 pi over 2. 7 minus 4 is 3 pi over 2, which is smaller than 2 pi for sure. Now here's the trick that I want to show you. I didn't want to show it to you at the beginning, but now you can see it. Actually, no, never mind. Let's move on. That works for the reference angles. I was just thinking of something different. Reference angles. Never mind. Let's do the next one. Negative 13 pi over 18. It's a negative, so we add 2 pi. So negative 13 pi over 18 plus 18 times 2 is 36 pi over 2. And then 36 minus 13. So that will give us 23. Why do I have a 2 in here? 18. Yes, 18 times 2, 36. 18 times 1 is, sorry, yeah, that's 18, not 2. I don't know why I had a 2. So 36 minus 13 is 23 pi over 18. And 23 over 18 is not greater than 2, smaller than 2, so therefore we're good. This is the coterminal angle. I mean, coterminal angle that is, that meets the condition that has to be in between negative 2 pi and 2 pi. Last concept you may have seen probably in geometry class. It's the arc length. Arc length of a central angle. So the arc length, which means the length of this arc of a central angle. Central angle is an angle whose vertex is at the center of the circle. So if we have an angle whose vertex is at the center of the circle, we call this central angle. And then the intercepted arc has a length, and there's a formula we can use to find the length. The formula we use to find the length is S equals R times theta, where R is in radians. So the measure of the, I'm sorry, not R, theta, sorry. The angle theta must be in radians. If it's given to you, it's given to us in degrees, we must convert it to radians. And the radius R, that depends. That could be in any measure. R could be in any unit. Means in feet, in inches, in miles, or depends on the question what they want. Any length measure. All right. So it's very simple. Example 6 says find the arc length if the central angle measures 60 degrees and the radius is 9 centimeters. So the formula says it is R times theta. R is 9 centimeters. And theta is 60 degrees, so must convert it to radians. So 60 degrees times pi radian over 180. We know that 60 actually degrees is equivalent to pi over 3. That's as we work a lot with the angle in angles in trigonometry, we're going to actually, that becomes automatic. 60 degrees is equivalent to pi over 3. So it's going to be 9 times pi over 3. 9 divided by 3 is 3, so the answer is 3 pi. 3 pi what? Centimeters. Because we are calculating the length of the arc, not the angle, not the angle that corresponds, the angle measure that corresponds to the arc. No, it's the length, how long it is. This is the end of the presentation, and thank you for watching.